Great. Okay, let's get started. Morning, everybody. Today we're going to be talking about two of my favorite topics, errors and promises. So who here's got an error before? That's just a test to see who's raising their hand. Sometimes there's like, oh, yeah. It's like, really, none of you? Yeah, so we all get errors before. They come in all kinds of different varieties. What kind of errors do you find you run into a lot? Errors related to undefined? Yeah, what sort of errors do you get? Sure, yeah, you declare something and then like maybe you call like a method on a variable that you created, but it doesn't have a value for some reason. Yeah, syntax errors. Those are a big one. Reference errors. Yeah, type errors. So if you try to say like do use declare a variable and don't give it a value, then you go try to call a method on it. The error that you get is a type error, right? What does it mean to declare a variable without giving it a value? It's a good question. So doing this is kind of equivalent, maybe literally equivalent, to doing this. So why might you want to do that? The reason that you're allowed to do this is because A, why not? Um, B, it's useful sometimes because of scoping issues, right? So if I create a variable out here, then I go then when I down here, if I go this is going to say undefined, right? But the second one is going to tell me 10, right? So if I declared the variable in here, now the variable scoped to this function, I'm going to get not defined here and not defined here. Does that make sense? So by declaring a variable out here but not giving it a value, yeah, I can control where the variable is scoped. So that affects what other code can use it. If the only place that I'm using this variable is inside this function, then it should go inside the function and get cleaned up later. So I don't have all these like stray variables running around my namespace. Does that help? Cool. Does it matter if you use var or let? Yes, it does, kind of. So the difference between var and let is var uses function scoping and let uses block scoping. So the scoping rules for let are a little more strict. So if I go let only exists inside of this block because it's scoped to the block level. Whereas if I put a var in here, that's still available outside of the if statement. Does that make sense? Cool. So yeah, the kind of errors that we run into a lot are type errors, syntax errors, reference errors, as you mentioned. That's one category of error. That's what we would call process errors. You might call those interpreter errors, right? Those are errors that come from JavaScript. So JavaScript is telling us that we're doing JavaScript wrong when we do that. There's another category of error that we get from, say you're using jQuery now, right? jQuery and Express. Do you ever get errors from those that say something like, hey, that's the wrong kind of parameter to pass to this? Something like that. Should probably be lowercase. Another place that we find that we get errors from is library errors. So it makes a difference, right, whether we're using JavaScript wrong or we're using someone else's code wrong. Does that make sense? So based on what the error says, if it says type error, then we know, okay, we did something dumb. And if it's an error that says that's not how you use jQuery, then you know that we're using jQuery wrong. So maybe the place to go to solve that problem is the jQuery docs, right? Another place you can get errors is in your tooling. Oh, that's why it keeps capitalizing. So I have a linter enabled. And it keeps telling me, it keeps giving me like these sorts of errors. What's that mean? Do y'all get anything like this? Is anyone here using a linter? Are you? Yeah. Yeah, so what's a lint error? It's not properly formatted. Yeah, yeah. Doesn't follow best practices, yeah. So a linter is a tool that you enable to basically give yourself more errors, right? So in this case, my linter is configured so that if I have a console log in there, it says, did you mean to have that console log in there? Because normally when you are finished your code and you commit it, you want to pull all those console logs out. Not always, but usually. So my linter says, you're not allowed to have console logs all over your code, so that's a problem. If I do something like that, it's going to warn me that this variable that I declared is undefined. So in this case, this will prevent the code from running, right? This console log won't. So linters give you all sorts of errors that make your code better, sometimes in critical ways, like, hey, you used a variable that is undeclared. And often that's a great way to catch typos before you run your code and it crashes and you go like, oh, I forgot the S. It also helps you keep your code clean and basically be accountable to the own rules that you set for yourself. So why would you want tools that give you more errors? Yeah, because errors in general make you more efficient, right? So we actually want errors, and we want descriptive errors. We want to know that if my code crashes, that it's because I called .for each on something that was undefined, right? We want to know that it's because I'm using jQuery wrong. So we want errors that are descriptive and useful and very pertinent to where the problem actually is. If we can get a line number, that's great, right? Go look at this line of code. This one's the problem, right? And that leads me to the last category of errors, that I could think of. And those are errors that we create ourselves. And that's one of the things that we're going to talk about today. So has anyone written their own error before? Is it something you've tried yet? We've done Mocha testing before and written errors for that? Okay. Okay. So what do those errors look like? Okay. So in that case, you were triggering an error in JavaScript. Okay. Um, okay. And how did Mocha handle that? Okay. Okay. So in that case, what you're doing is what some people call error-driven development, in a sense. When you're writing unit tests, especially, like the right place to start usually is make the test fail and then write code to make it pass, right? And that's sort of what you were doing with Mocha. So you're intentionally triggering an error. Um, yeah, so that's a good point. But we can actually create our own errors. So instead of doing something that causes JavaScript to error, we can just say, hey, when this line of code runs, this line of code isn't supposed to run. That's an error. It's real easy. Um, One way to describe like the verb that you use for when an error happens. See how that highlights? It means it's a JavaScript keyword. Throw, right? What am I going to throw? Yeah, a new error. Pretty easy, right? Um, See what that looks like in the console. Good in the back? Can you read that okay? Cool. Hey, cool. That looks like a real JavaScript error, right? So I have the message that I gave to the error. I have my whole stack trace, right? Um, what's this thing for? What's all this stuff here for? What does it tell me? So anything that happens afterwards is not gonna happen because we errored out. Yeah, not what I was getting at, but that's true. We're gonna come back to that. This is the stack trace. So this tells us this is hints about what exactly went wrong. So in this case, what I did was I threw this error at like the very top level of the process. So the only stack trace we get is all this node stuff. So this is all like internal node stuff that for the most part we don't care about. But it's a little clearer what happens if we put this in a function. Bless you. Then we run the function. Now we have a new line in the stack trace. Otherwise identical, but we have a new line. So what's going on here is when an error occurs, one of the things that it generates is a stack trace that gives us breadcrumbs back to exactly what went wrong. So where this error gets thrown could be deep in some like crunchy math library code or something like that. And so we got an error there, but not because of something that was there, something that happened a few steps up is what actually went wrong. And the stack trace helps us narrow that down. So if we go and look at, let's see. So this object anonymous thing, here's a file that I created, demo.js. And that's the first file in the stack trace that I know about that I created myself. So that's the first one that's in my control. That's usually a good place to start when you're reading a stack trace, is look for the files that you touched. So demo.js line 10. Okay, so line 10 is where I invoke this function. So that means when I invoke this function, that's where something went wrong. Then I look a little further up. I see that line 7 was the actual problem. Oh yeah, holy cow, there's like an actual error there. So was that a fun scavenger hunt? So what do we expect to happen now? Does, pardon me? Okay. So we think maybe there'll be another line in the stack trace because we're 2 layers deep now. Yeah. So here's the error. We go up 1 level and we get that first function we wrote. We go up another level. We get that second function we wrote. Go up a 3rd level and now we're sort of into like weird, I don't know how node works land. Like now we're looking at files that I guess if you look at the file, that's a hint that this is like the very top level code. And then you go one more and you're like, I don't know. That's node stuff. By the way, when you see this underscore, does anyone know what the underscore means in a method name? The underscore is like a JavaScript convention that means that something is internal to whatever this thing is. So that means module is calling this method on module. So you should never call an underscore method in your code, only that object calls it on itself. Kind of thing. It's just a convention to sort of help you notice like, oh, this isn't my problem. We'll leave that there actually. So when might you want to throw errors? Why would you want to throw errors? Don't you get enough errors? Is it for testing the unhappy path? Yeah. Yeah, you could say that. Yeah, it's kind of for, it's a lot like a unit test, right? You're saying that if this happens, that means something's gone catastrophically wrong, and I can't continue. So I might write a function, let's say I want to give my team the ability to take 2 numbers and divide one by the other. And there's like some secret JavaScript trick called that operator. But I don't want anybody to have to remember that, so I'm just going to write a function to do that. Let's imagine that makes sense. Fair enough? Cool. So my coworkers are going to start using this code now. Some of my coworkers are going to be me in the future, by the way. And we're going to see stuff like divide 4 by 2, divide. And that's all going to be good, right? Don't expect any problems there. I guess we want to log those so we can see what's going on. Wait, did I get not a number? Why did that happen? Oh. Yeah, good catch. So what actually happened here? Why did I get not a number there? Yeah, not nothing. There's no such thing as nothing, right? I tried to divide 5 by undefined. You divide anything by undefined and you get not a number, right? Little kind of computer science history fact. Not a number is kind of like before there was such a thing as like runtime errors or compiler errors. Not a number was this value that kind of like matched the bit pattern of a number, but it indicated that something's gone catastrophically wrong. Like it doesn't make any more sense to do any more math on this. So not a number is kind of like an error before there was such a thing as errors. So anytime you see this, something's gone terribly, terribly wrong, and you can't continue treating this thing as a number. So that's why not a number, you can't add anything to it, you can't divide anything by it, you can't do anything to get it to not be undefined anymore, or not be not a number anymore. Because it just says like something's gone so bad that I don't know how to recover from this. And that's kind of the reason that not a number is the only value in JavaScript that doesn't equal itself. What? And so that's why, because why are you, like, you can't compare this. It doesn't make sense to continue doing operations on this anymore. So if you're doing, like, if you're trying to test equality, like, you shouldn't get a positive signal. You should get, like, no, no, stop, what are you doing? Um, yeah. Yeah, not a number will always evaluate, if you compare not a number to anything, including not a number, it'll always evaluate to false. Um, so this was accidentally kind of an interesting example of, here's a way that someone, including like 20 seconds later me, uh, might do to like use this function wrong. So how might I describe what I did wrong here? In kind of like the general case that I could say, this is a class of thing that you can do wrong. Interpreter error? The interpreter didn't give me an error. It's not even really a syntax error in the sense that it's perfectly syntactically valid to leave off a parameter to a function, right? There's nothing wrong with the syntax here. There's nothing wrong with the operation I did. Like you can totally divide 500 by not a number. JavaScript's okay with that. Or 500 by undefined. JavaScript's okay with that. This is like an application level error. This is the intention that I had when I wrote this function and the way that it's being used don't match up, right? So that's a situation where I might want to write my own error because JavaScript's not going to say something's wrong here. As far as JavaScript is concerned, everything's okay. I, the developer who wrote this function, have an opinion about why this is wrong. So the thing that's going wrong here is what I'm essentially doing is I have a function that requires 2 parameters, and I'm only giving it 1. Right? So one thing that I might want to error on is, well, you didn't give me the right number of parameters. JavaScript doesn't have a problem with it. I do. This function isn't going to work if you don't provide that second parameter, right? So we can do a check, and we can throw an error. So what are we checking for? If there are parameters, right? So what's that going to look like? If A is true and B is true. If A and B. Yeah. So if A and B, that's like the happy path, right? So what I could totally do is wrap the happy path in the consequent of this flow control thing. But generally, it's better practice to have your happy path outside here and then have your bailout stuff at the top of the function. So if I'm going to bail out, I want to do all these checks and be like, okay, everything's okay, back on the happy path. And the happy path is like at the top level of the function. So that way I don't end up with like, 2,000 lines here. Not that you should have 2,000 line functions. Yikes, I take it back. But I can have a bunch of code here and I don't have to remember that like, oh yeah, I'm nested inside of one of these. I just do my checks up top. And it's just like, check this, check this, check this. If you didn't bail out, keep going. So I probably want to negate this. I probably want to check, I probably want my predicate to be if you're missing A or B. Right? So now, if either one of these is true, A is missing or B is missing, then that means you're doing it wrong, right? So we want to throw new error. Good errors have error messages. What do I want to communicate to the developer using this function? Yep. That we need 2 arguments. So I'm going to use backticks. Why am I using backticks? So I did a few things here. First of all, I made it clear where the error happened, that this is an error with how you're using this function. You could look at the stack trace and see, oh, that's where the function happened, right? But this is just a nice human readable way to say, look, the issue is with the way that you're using this function. It's like a caller problem. I described the requirement that wasn't met, and then I say what data is involved. Okay, cool. So now if we run this code again, nope, that's just Node. Cool. So I had a real hard time highlighting all that. So now instead of just getting not a number and going, what? We get this. We get a description from like another human that says, this is a specific thing that you did wrong. So that's good. Now, whatever I pass into divide now, it's going to work, right? We've covered all our cases. Someone's paying attention. Oh, it's the same problem as before. Interesting. That worked. You thought it was going to error. I did too. Why does that work? Yeah, that works because of type coercion. Show of hands, who's comfortable with the term type coercion? A couple of us? Is this the first time that any of us are hearing that? Because it's like hugely important to understanding why JavaScript is weird. It's like one of the weirdest things about JavaScript. Should we talk about type coercion for a minute? Who wants to talk about type coercion for a minute? Okay. Okay, so JavaScript does a whole bunch of guessing what it thought you meant. So it has rules for when you try to do things like add a number in a string. It doesn't really make sense because like with numbers you have this plan where you look at the value of this number and the value of this number and then you keep adding 1 to this number and subtracting 1 from this number until this one's 0. And then that's kind of like the algorithm for adding numbers, right? Adding strings, it's a little different, right? What happens when you add strings? Yeah. So strings are concatenative. You just stick one on the end, right? So if you have like number 5 and string 10, or sorry, string 5 and string 10, it sticks them together, right? Versus number 5 and number 10, it adds them. So when you add a number in a string, what's supposed to happen? Yeah, one opinion, I guess the answer to that is it depends on your opinion, right? Because adding a number to a string in a way is nonsensical. So maybe your response to that is like you said, well, adding a number to a string is nonsense, error. That's not what JavaScript thinks. JavaScript thinks, well, I see you have a number and a string. Hey, I can turn numbers into strings. What if I just turn that into a string for you? And then we just call it a day. Would always place emphasis on strings over numbers. The answer is yes if it can. So JavaScript, when you're thinking of type coercion, kind of like the secret to understanding or like guessing how JavaScript is going to do type coercion is think like, how's JavaScript going to turn this into a string? What happens when you turn this thing into a string? So what's going on here? I add an array to an object, and I get object. What about when I add an array to an array? What do you expect? One array? It's a good guess. Turns out to be wrong. In other languages like Ruby and Python, I think when you add two arrays, it just concatenates the arrays. Makes sense. JavaScript's like, no. Empty string. Oh yeah, good point. Yeah, that makes sense. So it's a little more obvious what's going on here if you look at what happens when you turn an array with items in it into a string. So here's a little trick. Whoops. Here's a little trick for turning stuff into strings. You can just concatenate it with an empty string to leverage this type coercion thing. So usually you put it at the front. And if you don't believe me that that's how you do it, you can just go use the string function. Okay, so what happens, what might be the algorithm for turning an array into string that JavaScript uses? Concatenate each element in the array to a string. Almost, yeah, almost. But where do these commas come from? You might say, well, right here, there's a comma right here. What are you talking about? But it's not really that, right? Because these commas aren't values. They're like they're part of JavaScript syntax. They're imaginary. They're for us, not for JavaScript. So what's going on here is like a join, right? So when you call .join on an array, we can put whatever delimiter we want, right? And it'll go like element 0 delimiter, element 1 delimiter, element 2 delimiter. And that's what happens when you can coerce an array into a string. So when we coerce an empty array, an empty array into a string, what do we expect? We're going to get all the elements in the array, separate them with commas, and give back that string. There we go. So when we go empty array plus empty array, what we're really doing is empty string plus empty string. And we get empty string. All right, that's all I want to say about type coercion for now, unless anyone has any questions about it. Okay, cool. Let's go back to errors. So I've decided that I think the parameters you pass should be numbers. Not because you can't do this, but because if you did it, it was probably by accident. This is some opinion that I'm putting into my code here. If you're going to use this function, you have to pass it two numbers. I know JavaScript does fine if it's like a number and a string, but then if you have like a string with that isn't a number, then that's bad and the code's going to break. So I'm going to tell you, I'm going to scold you for passing the wrong parameters to my function. Right? That's how I check if something's a number. That's one way to do that. I'm going to throw a different error. What's the error going to be this time? Pardon me? All arguments must be a number. Say both arguments. One other thing to help out probably future you, but also other developers. Yeah, what data is involved. So it's all well and good to say this is how you use this, but it's even better if you say this is how you tried to use it. Yeah. So you can see now how for this division function, we can actually take this really simple, what is an unnecessary semicolon? Thanks, linter. This really simple JavaScript thing, and then add a whole bunch of stuff that doesn't have anything to do with dividing numbers directly. It has to do with using the function, right? So we often have code that does one thing, but we want to set up constraints around how you use it. Like, this isn't going to work if the string is 2,000 characters long. It only supports strings up to 400 characters long, right? So we can build those constraints into our functions, into our code. And this is a little better than this, right? We're kind of writing documentation the same way that we do for comments, but there's a reason that doing this actual check here is better than just leaving those notes in a comment, right? When we do this check and we throw an error of our own, what we're doing is we're making sure that those are enforced in the code and that the code behaves in line with what we intended. So if we just give it comments, these comments are just like dead text in the file, right? So if you see someone import divide and you're like, oh, I'm going to use divide, and you like make a guess, like if I pass it a 10 and a 3, it like does some math on it. You're like, yep, that's what I expected. You're not necessarily going to see these comments. You're not necessarily going to go look at the source code, right? So when you build in these ideas into the way the code actually runs, you're making your code self-documenting, and you're giving your code the initiative to go tell the caller, hey, you're using me wrong, if that's an opinion that you have. So those errors are great, but in real life, you're going to deploy code out onto the internet, and people are going to be running your app, and they're going to be just like clicking around and, oh, wow, what a great app, and then crash. Your app blows up, right? Bad situation. In development, you want that. In development, as soon as something goes wrong, you want the alarms to go off, you want the air raid sirens, you want like the big flashing red like something's broken. So you as the developer can go like, well, I didn't mean to do that, and go fix it. You want to fail loud, fail early in development. In prod, you kind of don't want to fail at all, right? Something goes wrong, you can just kind of kick it under the rug. Pretend that that didn't happen. So what do we do to hedge against errors? Maybe it's another developer's code. Some other developer wrote some brittle code that's like 15 years old. Works like 85% of the time, so we keep it. But sometimes it just breaks and no one really knows why. Something about some like 3,000 line XML file with, I don't know. So we kind of depend on it, but if it doesn't work, we have a backup plan, but we don't want the error to just explode the whole app. We can tell JavaScript to, try running this code, and if it goes wrong, here's how you bail out, right? And that looks really simple. It's like, try to do this, and if an error is thrown, this is how you catch it. Is it kind of like a prevent default? And you're talking about like front end, like event bubbling? In a way, it's a lot like that. Yeah, exactly. You're taking charge of, you're not exactly taking charge of when the error happens, but you're taking charge of how the app responds, right? So the default way for errors to erupt is like an error is thrown somewhere, right? You try to call for each on undefined or something, and JavaScript goes, I don't know what to do, or your code goes, I was told to explicitly throw an error here, right? And that error starts going up and up and up. So it looks at the parent, the function that called it, and it's like, something's wrong. Do you want to do anything about it? No. Okay, go to the next one. Something's wrong. Do you want to do anything about it? No. Go to the next one. And keep going and going and going until you get to the node process, the parent process. And then when it reaches node, node's like, why am I and it just pulls the plug. Okay, so if there's no code in this whole stack that's prepared to deal with this error, I'm not handling it. I'm just gonna crash, right? So that kind of makes me think: why do we use the word throw for errors? Because we want something to catch it. Yeah. So there's kind of like the throw catch metaphor, right? Every programming language ever is designed to be easy, right? And they don't always succeed, and they have different opinions about what thing it is that they want to make easy. But every programming language ever is trying to make things easy, right? So the way that we name things is supposed to be helpful. So you throw an error, you try something, an error is thrown, and you have a plan to catch it, right? So like, what do you picture when you think like throwing and catching? And what's that like? I picture like, you know how when you go to like a sports ball game and they have like those t-shirt cannons and they like shoot it over the crowd, and then everybody goes like tries to get the t-shirt. I picture it kind of like that, and then a bunch of people like try to catch the t-shirt, and then if nobody catches it, it just like lands in the mud, and then nobody wants that t-shirt anymore. This thing that was really valuable, really high priority for a second, is like now kind of garbage, and you don't want it anymore. So I think throw is kind of like throwing a projectile in a sense. If nobody catches this projectile, it's going to go splat on the wall. Probably somebody should catch it. Also think of it kind of like throwing a tantrum. Like when somebody's throwing a tantrum, they're not really saying like, there's a problem that I'd like to fix. They're saying, deal with me. They're like, I'm going to be someone else's problem. I'm upset. I'm going to be someone else's problem. And catch is how you deal with that. So if we write some tantrumy code, right, like this divide thing, just make sure this still does the wrong thing. I'm going to use the missing parameter example. Function divide requires 2 arguments. Yep, works as before. So I'm going to take this, actually I'll move it, just move the whole line down into this try catch block. What should we do in the catch block? In some circumstances, what we want to do is go, oh, something's gone wrong here. That's okay. We have a different plan. Sometimes all you want to do is like, you just want to notice that something bad happened. Maybe you have like some text file that every time there's an error, you just like copy paste the error and stick it at the bottom of the text file. That's called logging. So it's not that an error didn't happen here, right? It's that something other than the parent node process handled it. So node didn't have to go like, yo, your code's broken, and yank the plug. We said, no, we've got it under control. You don't have to pull the plug. In the catch block, importantly, we also have the error. So this looks a lot like before I did catch at all, right? But as you pointed out earlier, before this error stop prevented our code from continuing to run, right? But we see now that at the bottom, hey, our code kept running. So we got an error popped up in the console, like, oh no, an error. But we didn't throw up. We didn't explode. Compare that to, if we have the code out here, now node has to deal with it, and we never get further down, right? So try catch is a good pattern for when you want to prevent explodey code from actually causing an explosion in your app. Use this sparingly, especially in development. Yep. Could you export these to a separate file where you would write all these catches? Yeah, you could. You could. So in the same way that I just have this, this function is just wrapped in a try catch, this function could be imported from somewhere else, right? So if the thing that I wanted to do was I wanted to write all my functions like normal over here, then have a file where I do all my try catches, and then have my like app.js file that imports the kind of try catch wrapped ones, then that's like totally a pattern that that you can use, that I would encourage actually. Yeah, if done correctly. Yeah, it's good practice if done correctly. So the caveat here is that we don't want too much to be kicking our problems under the rug, right? We want to make sure that the app doesn't fail in production, that it keeps chugging along. But if there's an error, usually we want to know about it in some capacity. Usually if there's an error, we don't want not a number going into our database for someone's account balance, right? We want to know like, hey, you tried to do something and it didn't work. So yeah, the catch with try catch is Sorry. The catch with try catch is that you don't want to you don't want to use it to pretend that you don't have problems in your code. You want to make sure that you're still being responsible and taking care of it. What's the console.warn? Good question. I'm going to switch over to the browser for this one because I think it's more interesting over here. Wow, GitHub has a lot of problems. These are all console warns, by the way. Is that... It's kind of hard to see, hey? I think that's... Oh, maybe I can... Okay. Well, you should be able to be kind of blind and still see what's going on. So we know console log. So if I go console dot, we can see all the things that you can do to console, right? And there's console log right there. We also have a bunch of other console methods that we can call, and these are like the console object is basically the object that lets JavaScript talk to the console. So we also have console error, console warn, console info. So I was saying earlier how just gonna not deal with that for now. How I have my linter set up to tell me about console logs. Sometimes I want stuff logged into the console, but I never use console log for it. I use console log for debugging. I use console log to kind of like shine a flashlight around what's going on in my app. And then I take them out before I commit. If there's something that I want to be in the app that I actually want to show up in the console, I use console info for stuff that's like... And I just get like a little info icon. Otherwise, it's basically identical to a console log. Console warn gives me kind of this louder, just a heads up. And console scream, yeah. And console error actually looks like an error, just like you tried to call for each on an undefined kind of error, right? It looks like the same sort of thing. We even get this stack trace. This isn't a very interesting stack trace. But that's the advantage to using console error. It kind of pretends that the message that you passed was a thrown error. So if you want to have errors in your code, but you feel like actually throwing an error and then like trusting that some other code is going to catch it, you feel like that's a little too intrusive. Console error and console warn are good places to do that. Good tools that you can use for that instead, because they don't actually break your app. They have kind of like the try catch built in. So in the code that I write for work right now, I have like a console warn where I'm doing like this hacky thing where I take like the state in my React app and I just attach it to the window object, so I can just pop open the console and like look at all the data. And so I have like a big loud console warn in there that's like, hey, you're still doing this, take this out before you push that out. And that's like a note for me to say, okay, if I don't see this, someone's gonna see this. And it's just like a sanity check to make sure that I'm not, it's like a little better than a comment to do, take this out, right? I put a console warn in there that says, hey, I'm supposed to tell you don't do that. And then the console error is like, I'm supposed to tell you this went wrong, and here's the stack trace to show you where. And then in console warn, and then in Node, if you're just looking at it in your terminal, it doesn't look really that much different than, this is an actual error. If it's like so the error prints out the error with the stack trace and everything, right? If I just put like a string in here, it doesn't behave really much differently than a console log. In Node, in the browser, it's very different. Cool, so I think that's all I want to say about errors for now. Does anyone have any questions about those so far? Any thoughts about errors and apps exploding and things? Let's take a quick break. When we come back, we're going to talk about promises. 10 minutes? Okay, let's get started again, everybody. Think everybody's back? Great. So we're going to talk about promises today, second half. Promises are kind of a weird idea. They don't really make sense if you think of programming as a procedural thing, right? So what do I mean by procedural? Procedural programming is kind of when you first learn to code, you write things line by line. They say declare your variable up here, do some stuff to it down here, log it out down here. You do everything. Everything lines up like this. It's just this top to bottom thing. A runs and B runs and C runs, then D runs, and then your program's done, and the script ends, and you say, "Good job, script. Good job, me. I'm a programmer." Then you start working on applications, and you notice that when you start up a web server, it doesn't have that same property exactly. It's like A runs and B runs, and then you have a whole bunch of code that doesn't really seem to do anything, and then you get like app is listening on port 8080 or whatever, and all this code in C hasn't run, and the app didn't exit when it was done. Well, that's kind of weird. What's going on there? And then you find out like, oh, I can make HTTP requests. And so when the server receives a request, then some of the code in C runs. Okay, so it's not doing A, B, C, D anymore. It's not just going through a procedure, like a recipe or something, right? We're going A, then B, and then something's getting like set up in Express, and then it's waiting for some sort of event that is going to happen at some indeterminate time in the future, right? You start working on a front-end app. And front-end apps are very asynchronous, right? You have all this different behavior happening on the page at one time, right? You have like a message box that's updating just every second or something. It's like phoning home. Do you have any messages for me? No. Okay. Do you have any messages for me? No. Okay. Meanwhile, you have a form on the page that's waiting for you to type something in, and as you type something in, it's going to be like, that's not an email address, but only when you add something. And then you have like some other code that's gonna handle like when you click submit, and that's not gonna run until you click submit. And so your app ends up broken up like this, right? Instead of going, A, B, C, D, you have all these different behaviors defined, right? So you have a particular behavior for what happens when you submit a form. You have a particular behavior for when you click this button, and then when you click this button, you use the same behavior again, right? That's what this is supposed to represent. I don't know if it makes any sense. And then you have some other behavior for maybe when you click this button, it makes an API request. And then when it gets a response, it has like some other plan for dealing with that response. And pretty soon, this model of just going line by line through your code, running a script and then exiting, kind of breaks down, and you realize that's not really the game anymore. Like you're a real programmer now. You're in async land. So with that in mind, does anyone want to take a stab at describing what about this makes it synchronous, and what about this makes it asynchronous? Not all of those things need to happen in order for your app to run. Yeah, exactly. They can you set them up, and then you wait for something else to cause them to run, right? And if this button never gets clicked, the app is still fine, right? There's this property with procedural code, and with all synchronous code, we'll find that D is dependent on A, B, and C, right? C is dependent on A and B. So we have this dependency chain here, where D shouldn't run. I mean, whether it turns out to be true or not that D can run, it shouldn't run until A, B, and C have run. So when we're writing asynchronous code, we want to apply this when we need to. You'll notice that A to B is still synchronous, right? So the reason that there's this arrow here is because B shouldn't run until A happens, right? The form shouldn't submit until the user fills it out, click submit, right? You shouldn't try to if you make an API call to go get I don't know, the weather or something, you shouldn't create that new node in the web page until you've gone to get the weather, right? So when we're programming asynchronously, it's not that we never do this, it's that this isn't the whole story, right? So the reason I drew this out kind of all over the place like this was to sort of illustrate that even though our text file still goes line by line, the order doesn't necessarily matter, right? If you think about some of the apps like your Tiny app or whatever, you can move a bunch of that code around and it doesn't change how the app works, right? That's not true in purely procedural land. Right? You can change where functions are, you can set up your event listeners in different places, and it all still works the same way. That's because you're doing this. You're defining behaviors. You're defining behaviors and their dependency chains. And you're creating these encapsulation barriers around the synchronous parts of the app. So these big circles are asynchronous. The little circles are synchronous. So promises are a tool for helping us do this, create these synchronous dependencies, and encapsulating them so that the rest of the app can behave asynchronously. And that's really important for JavaScript. Not all languages work this way by default, by the way. But JavaScript is very much an async first app. If you learn Python, then one of the things that you eventually deal with in Python is oh yeah, how do I do anything async at all? Let me think about that. And you have to go out and figure out how to do it. In JavaScript, it's you're just kind of coding along, and then suddenly you're doing something asynchronous, and you're oh, that's weird. What's this async thing? So JavaScript is an async first language. Why is that? Why would JavaScript be async first? Has to do with what JavaScript is for. What's JavaScript for originally? Little history trivia. Does anyone know what JavaScript was initially developed for? The internet? Yep. Yeah, it was invented for the internet, specifically for web pages, right? JavaScript was invented to add interactivity to web pages running in Netscape Navigator, I'm pretty sure. But yeah, it was about adding interactivity to web pages for the internet, right? And we know some things about how the internet works. It has these things that happen very fast, like repainting the screen when you scroll, right? It has to take its opinion about where all the pixels are and then kind of rethink that when you scroll a little bit. And it goes oh, new set of pixels. That happens very fast. And then it has things that happen very slowly, like making a HTTP request to South Africa that has to travel quite far. And so it takes orders of magnitude different amounts of time, right? And when we're talking about interfaces, buttons and forms and things, interfaces don't necessarily have any built-in, you can't predict when an interface is going to be used. And you don't want to do that, right? You want to say this button is listening for a click, and when it's clicked, its job is to do whatever D does, hand off control to D, right? Just pass the ball along. So JavaScript wants to be async first for that reason. So when we're talking about promises, there are kind of three levels to come at it from. One is sort of the high level, like philosophical, like computer sciencey concept of like what is a promise as an idea. The other is what are promises as like a JavaScript language feature. Like when I type capital P promise into my console and press enter, like I get something. What's that thing? How do I work with it? And then the third way is, okay, so when I run into promises in the wild, what do I do with them? You know, you import connects, you connect to your DB, you make a query, and then you go, promise. What do I do? And luckily, if I do a good job of explaining the first two, the third one is actually really easy. Promises make that part of it really straightforward. So hopefully that'll, hopefully we'll stick the landing on that. So I'm gonna get like a little bit abstract here. So if you get kind of lost with like, okay, yeah, but like what are we even talking about here? You can think of promises as, in practice, what you're doing is usually database queries and API calls. Right, so what promises are, like in principle, is when a process hands off control to another process to do some work, and then the definition of the plan for what to do when you get control back. In practice, that's almost always database queries, API calls. Just keep that in your head. We're mostly talking about your node code or your front end code. We're mostly talking about your node code making calls to a database or to like another server, or your front end code making calls to your server. Go on a whiteboard, or do I want to type? Whiteboard. Okay, so we were talking about procedural programming a little bit. And with procedural programming, we kind of have this like concept of computational sequence, but they don't have really the concept of time, right? So the basic plan without promises for doing async code is you have some function that gets called. Say get users, gets all my users. And then one of the things it receives as a parameter is a function. What kind of function is this? It's a callback function. Thank you. Yeah, it's a callback function. So the thing that the callback function does is, well, it doesn't matter what it does. Point is, it does it later. So when you first start using callbacks, the thing you want to do often is like invoke the function here. Then you don't get the result you want. The thing that we're doing is we're like giving this function to this piece of code to run later, right? So this function gets called, and then we create this like big function scope. And then like some stuff happens. And then we go, great, we're done. And then invoke the callback, right? And callback creates its own function scope. And all of the context from this function gets carried into this function. And this has some problems. So one of the problems is that thing that I said about all this context being carried over. I guess I should preface this with saying that like the problems that you have like don't come up that much, and if you like write clean code, you barely care. So like we're gonna talk about like callbacks versus promises. And I'm gonna be like, no, you guys should really use promises. They're so much better. The truth is like promises and callbacks aren't that different. They're kind of like I kind of philosophically prefer promises, and promises are a little easier to work with. But if you're comfortable with callbacks, like that's still a good pattern. So the stuff I say about callbacks, don't take that as like never use a callback again, because like callbacks are fine. It's like I'm arguing about like Coke versus Pepsi. Well, if one of them was like objectively a little bit better, which maybe it is, I don't know. So we bring all this context with us. Another problem with the callback pattern is that this callback is probably going to receive a parameter or some parameters from its caller, right? So get users is going to like probably go to the database and like get some users and come back and like dump them into this function, and the function's going to run, right? And then in this function, I have the expectation that I'm going to like make an API response to like a front end app or something. But what parameters this callback gets are not guaranteed, right? So with your connects code, you kind of have to, you try something, and then you have to go look at the docs to see like, okay, well, what was their plan for what I was supposed to do? Promises are always the same interface. It's like I do my work and then pass the ball. And then I do my work and then pass the ball. So instead of doing this like nested thing, right, where this thing and this thing need to like have an agreement about parameters, promises let you just do like, I do my work, and I pass it on. I do my work, then I pass it on. And at each stage, all you do is pass on the result. There's one parameter. There's one thing you need to know. So you don't need to know anything about something that uses promises, other than that it uses promises, and then you can start using it. And you can just go look at what the result is. Like I know it's going to put a ball in my hand, and I just have to like look at the ball and be like, oh, this contains like user data. And it always works the same way. And so like you can remix your promises. Like imagine having all these like nested callbacks, and you have to like pull all this code out and then like take like some of the code in here and like put it back up here, and you have to do all this like splicing and stuff. It gets messy, right? Promises don't have that property. You can just make them in like a nice sequence. You just say this thing's going to happen, then when it's done, it's going to hand off the ball. Then this thing's going to do what it needs to do, and when it's done, it's going to hand off the ball. So have this like very clear sequence that lets you do this thing. So when you see a promise chain, you know, I have like some dependencies that I've laid out, like these things need to happen synchronously in this order. And outside of the promise chain, like you don't need to worry about it. So that's pretty cool. I do want to mention the, we talked about the throw analogy earlier. Like how do throw and errors go together? Does anyone have any intuition about promises? Why they're called promises? We're promising that everything is going to run properly in that function. Yeah, so this function is kind of this first thing. This first promise is saying, if this succeeds, I'll let you know. You can't really guarantee that it's going to work out. But yeah, it's kind of that. It's sort of like it's sort of like I'm going to go do this work and it's not done yet, but I'll let you know when it's done. Right? So the reason I bring it up is because I think the promise analogy is mostly a bad analogy. Like if you think too hard about like how is this like a promise that I make to a friend to like pay them their money back or whatever, I think it kind of leads you astray. So I think it's important when we encounter analogies and we're like, oh, that sounds like a thing in like meat person life. And I'll tie it to this computer concept. It must be the same in some way, right? You should sort of try to like find the boundaries of, well, how good is that analogy? I think the promise analogy is pretty bad. I think it's useful insofar as it has like this defer to later property. It kind of describes like, okay, when you're doing a promise, what you're saying is, I don't have those users yet, but I promise that I'll go get them. And so promise is kind of like an IOU. But other than that, I would really resist the temptation to think of it too much in terms of like, promises are a meta value that represents a computation that hasn't been fulfilled yet, and are therefore like me promising to return a shirt that I borrowed to a friend. I'd resist that temptation. Promises are a plan for handing off control to another process and then having a plan for when you get control back. So yeah. Any questions so far about philosophy of promises? Okay, let's talk about promises in JavaScript. So as a language feature, we can like type capital P promise and we get something, right? It's like a function. That doesn't tell us that much because if we go, object, it's a function. Array is a function. So insofar, like we shouldn't think of promises as any more like functions than we think of like arrays as functions. So like they kind of are in like a way that we normally don't talk about them in. But they're a thing, right? So like we can go in the same way that we can go new object. We can go new promise. We get a type error. This is a lot like the type error that we got when we tried to pass one parameter to my divide function earlier. What's that error say? I mean, what does that error tell us? We're missing. Yeah. So it says the resolver is undefined. So we kind of have to know what a resolver is. That's a word that's like a little esoteric. So if you don't know how promises work, you're like not helpful, right? If you do know how promises work, then you know that promise receives a function, a callback function. And the thing that we pass is not a function, it's undefined, right? So a promise has to receive a function. The function receives two parameters. And these are going to be, these are functions that the resolver receives from the promise. And these kind of look like rec res in Express, right? So you might feel like in Express, when you write an Express route handler, at the end you don't return from the route, right? You don't return something. You respond to the request. You go res.send or res.json or something, right? Resolve and reject are kind of the same thing. In a sense, they're both like the response in Express. So inside of a promise, instead of returning from the promise, we either resolve or we reject. So the thing that you said about the promise is going to guarantee that it works. It's going to make sure that the code runs. It can't make sure that the code runs, but it can make sure that it only does the resolve if the thing works out. Otherwise, it rejects. So kind of a not very interesting promise might be like, might be something like that. So we're doing some kind of check. If we're happy with the result, we resolve. If we're unhappy with the result, we reject. And you'll notice that this is synchronous code. This is like this, right? So in this case, promises don't require you to hand off control to like a database or something. They let you put whatever you want in here. But if you are handing off control to like some database code, like connects or something that makes a HTTP request, then you can make sure that resolve isn't called until the request is done or the query is done. And the good news is you don't really have to do that usually. Almost all of the promises that you use, they won't be this. There'll be something that Connects wrote for you that returns one of these. So if you ever like using Connects and then you console log the thing that you got from Connects and it says this is a promise, you get something like this back. Then you go, okay, great, I'm in promised land. I know what to do. Or I know what to do, and I'm going to tell you. But this is how they work on the inside. They either resolve or reject. If they resolve, then they run like the next bit of code. If they reject, then, well, you get an error. So let's say we have so as soon as I do this, I'm saying I'm kicking off this piece of work. I'm handing it off to someone, which in this case is just like myself. I'm just like running behind the curtain and like doing some stuff and then coming back, right? But I'm handing off control to someone else. When I get control back, I want to have a plan for what I do. So all promises work the same way, mechanically, in terms of like, insofar as they're promises. All promises work the same way. As soon as I have a promise, I know that it's going to resolve or reject. I know that because it's a promise. If it resolves, then this is gonna I'm gonna get to do this stuff in here. If it rejects, I'm gonna do this stuff in here. So let's start with .then. .then receives a callback, right? So like it's like the Pepsi Coke thing again, except imagine that Coke was actually just like Pepsi with like salt in it or something. So this is going to be a callback function. The callback function receives one thing that I mentioned earlier. So anyone remember what then receives? Right? So this happens, then you hand off the ball to the next thing. That's what .then is, right? It's like do your work, then hand the ball off, right? What's the ball? Yeah, it's whatever you resolved. So in this case, we resolved just this string. But this string could be instead of like being a string, it could be like a bunch of users from the database, right? It could be the results of a database query. It could be a JSON object that's the result of an API call. But the cool thing about promises is that you don't have to know what it is to use the promise. You can just say, do whatever you do and then give me the result. Oh. Just making sure my linter isn't complaining about something important. It doesn't like that I have if true. It's like, that's always going to return true. You must not have meant to do that. Not a JavaScript error, but like you probably did something wrong error. So if I run this code, what do we expect to happen? Any ideas? Create a promise up here. And then I do stuff with the promise down here. I think it's going to console log woo. I think so too. Let's see if that happens. Yeah. Yeah, it did. So that happened pretty fast, right? Because this is actually synchronous code. But if it was an API request, like we might notice that it takes a bit. And that's important because we don't want this code to run until this thing is done, right? And then our promises often complain at us if we don't like handle the error case. So just like we have try catch in like, normal JavaScript, promises also have like their idea for how try catch is supposed to work in promise land. Right? So if I change this to false. As far as the promise is concerned, if an error like a JavaScript error happens in here, that'll trigger catch. Also, if the promise rejects, it'll trigger catch, right? So reject is kind of like when we create our own custom error and we say, this is not what's supposed to happen. We better let the user know about this. It's the same sort of thing. So far, so good? So important to know about promises is that as soon as you're in promise land, you're stuck there. Not really, like you can wiggle your way out if you want. But promises have a really strong opinion that like once you're in promise land, you should stay there. That means that this data that you're asking for, it's not like you like go into the promise and then like go and grab the data and then come back out and then go back to this. Right? So it's not like A runs and then B runs and B is a promise. So B goes off and like gets some data, then comes back, and then you do CD. You don't do that. It's like what you're doing is this. You're defining like this behavior chain where like the promise chain itself is like a particular behavior. It's like a discrete behavior that has like a boundary around it. Right? So sometimes people will try to do this sort of thing. Right? We'll try to return the result in here. And we're expecting that surely we're going to get that back out here, right? And then if down here outside of the promise, I can go and console log result, and it's going to be there, right? Well, no, it's not, because the only thing that you return from promise is another promise. Oh, that's a syntax error. Oh, see, it complains if I don't have the catch block. That's right. Change this back to a true. Oops. There we go. That's what I was trying to do. So when I console log result down here, I get promise pending. Right? And what I should think when I see that is like I'm looking at a promise from the outside, right? I'm not looking at one of these things. I'm looking at the barrier that I drew around it. Right? I'm looking at some code that's like defended from impacting the outside world. It's like safe from async land. It's doing its synchronous thing internally. And I'm not really like interacting with it at the right level when I see this come out. Right? It's not an error. Like that's a totally legitimate value. That's like saying like that's some behavior chain that's doing its own thing and don't worry about it. And what that means is that if this turns out to be a promise, well, that means I can call .then on it, right? So this isn't doing any like crazy database stuff, right? So I can just go .then. And what does .then receive? The previous promise just hands off the ball to the next one. We know exactly what goes in there. We don't have to look at like the function signature or look at any docs. We know it gets some sort of result. Then we run it again, still a promise, right? Everything a promise returns is a promise. You're in promise land now. So if you want to do something like respond to an HTTP request, you don't go get the data, then come out and then like do it outside of the promise. It's like you enter into the promise, and what you're saying is the code that runs inside of this .then depends on the stuff before it. So that code can only run if this promise resolves. Right? And the thing that we map that to is with something like a database query is you're only going to respond to this HTTP request after the database has come back and found a user for you and put it in there. We don't want any code that's like, you know, I told the database to go look something up and I'm just twiddling my thumbs till it gets back. We don't want to do that. We don't want to have like something over here reaching out into some other behavior. We want all these behaviors like nicely encapsulated. We're going to look at an example now. Does anyone have any questions before we move on? Could we pass resolve a function? Can you think of an example? Yes, you can. I could probably give you a more interesting answer if you had like a particular use case in mind. But yeah, I mean, you can pass anything to the resolve. It's just like just how you can pass functions to functions as parameters. Resolve is just a function. So yeah, there's nothing stopping you from doing that. Can't think of an example of when you would want to do that, but you totally can. Oh, yes, I can. It'll come up later. It'll come up very soon, actually. So I made this app for today called GoodWords. I'm going to launch it for you. Did anybody else get the app? Like clone the repo and like get an API key and stuff? Okay, that's fine. I did it. So this app's pretty simple. It's just an Express server that serves up one page. It listens on port 8080, which you might be familiar with. That's weird. Okay, I guess we're using Chrome. It's real simple. We type a word in, and it looks up that word. What's a word that you want to know the definition of? This is like a softball question, you guys. Word? Okay, let's look up word. So this is pretty simple. It just goes and gets definitions of words and like sticks them on the page. So the way it does this is the front-end server asks the Express server, hey, can you go get me the definition for this word? The Express server goes, okay, I know where to find that, and it goes and makes an API call to the Oxford Dictionary API. Oxford Dictionary API has like, they probably have like someone with like big glasses on that like goes through like a book and like types out the definition for me and sends it back. And the Express server sends it back to the front end, and then we render it onto the page. Okay. So the thing that I want to analyze here is where the promise is going to be. And the way to think about that is where are we handing off control to something else? Any ideas? Yeah, can you say that again? Yeah, so that's where the control handoffs are, right? The front end is going to do all that it can do, and then it's going to hand off control to the server. And it's going to say, I need you to do some work now. Let me know when it's done. I have a plan for what I'm going to do with the thing you give me back. The server goes like, okay, I'm on it, because that's what Express does. It goes and it asks Oxford Dictionary, hey, I have some work that I need done. Can you go do it for me? And then when that's done, they have an agreement about how Oxford's going to say, okay, I'm done. Here's what I got. And then I have a plan for doing more stuff, right? So what it ends up looking like is, I'm going to draw a sequencing diagram here. Okay, so the client is going to make a request to the server, right? The server receives the request. It's going to make a call to Oxford. Oxford is going to reply. So the client asks the server asks the API responds to the server, and then the server responds to the client. And then the client has a plan for putting the node on the page. I got real lazy with the writing stuff out, writing out what's actually going on there. Yeah, hopefully that makes sense. So every time control is handed off here, we're into promised land, right? So there's kind of a behavior chain where the client says, I'm gonna go defer this work, and then when I get it back, I have like some behavior that I'm gonna execute. So let's look at what that looks like a little bit. So this is the money right here. So all I have is I just grabbed the button element on the page and I set up a click handler. The click handler does some stuff. One of the things it does is it looks up the value of the input box and then makes a fetch request. Let's zoom in on that. Fetch is a great API. Has anyone tried it? No? Fetch is a great API built into your browser that lets you do those AJAX requests without like needing jQuery or without needing some external library. It's just built in. So the way that you used to have to do like built-in like native API requests was called some name with XML in it that I don't remember because it was bad. And all this config that you had to do, and you had to tell it this is going to be an HTTP request, and here are a bunch of details about what HTTP is. Like a browser doesn't know what HTTP is. Fetch simplifies that massively. You just pass it a URL. You can pass it like a bunch of other stuff. Like if you're doing a post request, you probably need to like you need to tell it that it's a post request, and you need to tell it what data that it's sending over. But just for a simple GET request, it just looks like this. So this is the word I typed in. I'm going to hit /words. Now fetch does have this weird caveat where the thing that you get from the promise is a stream. And it's kind of a weird choice in my opinion to kind of make you have to like think about streams as a front-end developer. But it's just sort of like this transport level, here's the data coming in bit by bit. So you just have to know that the way that you deal with a stream is you just go, turn the stream into JSON, please, then pass the ball along. So I make this request. The request hands off a stream. I happen to know, because I like looked it up somewhere, that we turn the stream into JSON, then we hand the ball off, and then that's like our actual JSON response. They have another function that parses through the response. The response is like messy. It gives you like all the like hundreds of different attributes about like the word. So I kind of just like sift through it and pull out the definitions so that I can put them up. And then I do some stuff, right? So in one of these other functions, I set loading to true, and that's how you get like this gray screen that shows it's loading. So one of the things that is dependent on the fetch finishing is I set loading to false again. And then the other thing that's dependent on the fetch finishing is actually like putting that new node onto the page. So that's promises. That's like this thing. It's like this part. I'm going to hand off control to the server by sending a request to words/word. And then it's going to do a bunch of stuff that I don't care about. But when it's done, it's going to tell me to run this. And then that's what this stuff is. On the server side, it's just an Express app, hopefully kind of familiar. Here's the part we're interested in, right? So instead of like ID like we're used to, I just had word. So that means this shows up in my rec.params.word. I have this function lookup word. I call .then on it. What does that tell me about what this function does? It's a promise. Kind of more importantly, it returns a promise. So the function itself you don't talk about as a promise, but you would talk about the thing that it returns as a promise. So this function might do a whole bunch of other stuff that's not promisey at all. But at the end, it returns a promise, and then whatever a function returns, you can just call like, you can start calling methods on. You can start treating like, you can start treating it like anything. If you have a function that returns an array, you can just call for each on it right away, right? You don't have to put it in a variable first, and then you can just start treating it as the thing it returns. So that's what I'm doing here. So when I'm looking at my route handler, I can encapsulate that thing where I have to like go ask the API and they have to like go through the dictionary and like send me back a response. I can encapsulate all that, so like I don't have to think about how that works at this level. I can just say, go look up the word. I know that's an async thing. No worries. Here's my plan for what to do after. I get a response from the API. I send it back as JSON. So that lets me make my route handler just really, really thin, really, really small. So the only responsibility of the route handler, it doesn't have to know how the API works. It just has to know to go ask for that. And then how the API works is like I have all these options and stuff. I have to pass it my API key. There's like all this kind of like crunchy details about how to go make that request. And then the thing I return is just this request object. And this is a JavaScript library called request promise native, meaning requests that use native promises. So I know from reading the docs that this returns a promise. So when I return this, I know that up here I can just, get into promise land. And you'll notice that I don't do something like this. This is a pit of despair, and you don't want that. Right? I'm not like going into promised land and then like pulling this value out and trying to use this. This is the wrong way to think about it. It's like you go into a promise and then the work that you want to do is done in that promise, right? So that's like staying inside of your synchronous module. You don't want to like reach outside of the synchronous module to do stuff usually. So that exists in there. So you're going to be doing all this API stuff, some of you, for your midterm projects. And I want to encourage you to think in these terms. Make your route handlers really thin, where this function hands off control to something else, and then has a plan for when it gets control back. And we do that with promises. Then that way you can write all these, you can encapsulate all of these particulars of how the Yelp API works or how the Google Maps API works. You can encapsulate them into some function and then just use that as like an abstract concept. Go look up the word for me. Like what that really means is, configure a request in this way and like ask for it in this particular way and deal with the response. We can encapsulate that and just say, go look up a word for me, then do this. Um, I think that's about it. Is there anything else you want to know about before we wrap up? Okay, there's two more things I want to put on your radar then, before I let you go for real. Um, one is promise all, other one is promise race. So one of the problems we run into with callbacks is that it's hard to put like many callbacks, like, and you have different branches. Like I want to make like 3 different API requests. I want them to kind of happen all at once. Like I don't need to make them happen one after the other, but I make them, like I kind of just nest them inside each other because like I don't know how else to do it. With promises, you don't have to do that. So if I have something like, look up word, and I have like 10 different words that I want to look up, right? Each of these makes its own request. Each of these makes its own request, and like it's gonna take as long as it takes, right? So we can kick these all off at once, and we don't have to go like dot then, dot then, dot then, dot then, and do them in order. These are promises, and promises are just values, right? So we can just wrap them in an array. And with promise all, we can treat them as one big promise. So instead of doing this really ugly nesting thing that's like, what's even going on, we can just treat them as one big promise and just have one big old dot then at the end. And then we get all of our results. When all of these promises have resolved, we get all the results as like an array. So each one of these promises turns into like a word object, like what we render on the page. Say for some reason we only care about like the first word to return, like just whichever one happens to finish first. Just give me that one. So promise race does. So that one doesn't come up a lot. There aren't a lot of use cases where promise race like really makes sense. But like for example, you might want to like render like the current temperature on your web page, current temperature for the user's city. So you have like 4 or 5 different weather APIs, and sometimes some of them don't work, and sometimes some of them are slow. So you just hit like 5 of them, and then whichever one returns first, you're like, okay, that's what promise race is for. So I just want to put those on your radar. If any of you are doing the smart to-do list, this might save you some heartache. And that's it. Thanks for listening, everybody.